friends, welcome to Answer. So today it is the 59th episode in the biology series. So today we're going to still discuss about another immune cell. So today we're going to discuss about the natural killer cells. Yeah, so these are also another part of the innate immune system. So first let's just draw the cell. So the cell approximately looks like this. So this is the natural killer cells. So even though they are in the innate immune system, they are closely related to the T cells too. Yes. So the main enemies of these natural killer cells are not bacteria. They attack viruses, especially the infected cells. So yeah. So they again remember, even though they are in the innate immune system, they are very closely related to the T cells which are in the adaptive system. Yes. So okay, let's start. So first, one normal day, but suddenly a virus infection occurred. So hundreds of cells are dispatched, and within a matter of weeks, the natural killer cells arrive. Yes. So here it is a virus infection, not a bacterial one. So then, you know what viruses do. They come, they just infect cells, they make hundreds of copies of themselves. So here is a normal cell doing its own business. Then suddenly, let's take another color for this. Many viruses enter inside of it. And now it is an infected cell. So another thing you need to remember are MHC class 1 molecules, or not exact molecules but something. So they are on this, like the cell membrane of the cells. Yes, all cells have these MHC class 1 molecules. I'll just call them MHC receptors. Yes, because they are receptors. Yes, so they are just like windows on top of the cell. So normally when cell is just doing its function, it will just show what they are making from the ribosome to the top of the cell, where then when any just normal killer T cell or the natural killer cell is just going on, they'll see here, yes, you are a perfect cell, okay, I will just go away. So that happens, to say simply. But when it is infected, it closes many of its MHC class 1 receptors. Yes, so the virus forces the cell to shut down many of them. Just like when many thieves come into the house and they attack a family, like the thieves will threaten the family to close all the windows and doors. Exactly like that. Yes. So like that they'll shut down many of their MHC receptors. So then they can't show their virus receptors. I mean the virus parts which they are making. Yes. So if they didn't shut down their MHC molecules, receptors, then a virus will come. It will look, oh no, you are an infected cell. Before I didn't say virus, I meant to say a natural killer cell or like a T cell. Yes. So when a T cell looks down, then if it sees any virus proteins, then it orders the cell to kill itself. So then that happens, and yeah, that will happen. But here is where the NKC comes. I'll call the natural killer cell as the NKC here. Yes. So think of there are other cells. So red blue. If there are blue dots, that means it is infected. So here is one incident, and here's another situation. Yes. So one situation is where one of them is an infected cell, and this one in the situation is there are no infected cells. So we'll draw the NKC in the black color. Yeah. Okay. So first let's do the situation with no viruses whatsoever. Yes. So the natural killer cell just goes on. It will now. So if these cells are stressed, then that means they are infected. But if they are less stressed, that means they are not infected and they're just doing their own business. Yes. So, and again, the natural killer cells will check this, and again, these infected cells will shut down lots of their MHC receptors. So these natural killer cells will again check that. So here they are perfectly fine cells here, just doing their own business. So the natural killer cells leave them alone. And so let's take an example. So think of a very nervous agent. So that nervous agent is the natural killer cell here. Yes. While all of these other cells are just normal common people walking throughout the city. But this nervous agent, instead of saying hi to them, takes a gun, and if that cell doesn't show its passport in time, the natural killer cell will shoot it and kill it. Yeah, that is what will happen. Yeah, okay. So one scenario is complete. And also one thing, if these cells are not infected, they will just send cytokines that says, we are not infected, just go away, we are doing our own business, like that. So one situation is completed. Next, the situation where a virus has infected. So first these cells, just normally what happens, let's make them also virus infected. So all of these cells are infected cells too. Yes. So finally the natural killer cells come. So here is natural killer cell. So yeah, it just checks the cells. So then they didn't show their passport. That means their MHC receptors, most of them are closed and they are very stressed. And they are now sending cytokines to just go away. Yeah, so then that's a very bad sign for those cells. And yeah, they're as good as dead. Because then this natural killer cell will say to that infected cell to just kill them itself, known as apoptosis. Yes. So then these cells will die, and that's the good ending. But if these natural killer cells are again infected, that's the very bad ending. Yeah. So this is for today about the natural killer cells. Bye.